This is the video recording for chapter 12.3 on the use of product rule. Now, a reminder, up to this point, we have learned about the power rule, we have learned about the constant multiple rule, we have learned about the constant rule. Now, out of these three rules, there are two special cases that we have to memorize. Right? For example, when y equals to 5x, the dy dx must be 5. You must memorize this. And when y equals to x, the dy dx is 1. Next, we went into topic 12.2, which was on the chain rule. Now, chain rule says that when there's a bracket and there's a power outside, you can immediately begin chain rule. And the chain rule says that the power 5 must come down. Whatever was in the bracket, leave it untouched. The power minus 1. And then the last bracket here is the result of differentiating the inside of the bracket. So differentiate 2x gives a 2, differentiate 1 gives a 0. Then the 5 times 2 gives a 10. The power now becomes 4. These are all the things that we have covered up to this point. We will now go and start 12.3, which is on the product rule. Let's begin. Now the product rule simply says, when your original equation y is made up of a product, that means there is a function multiplied by another function. There are two things that are multiplied together. You have to begin something known as the product rule. Now let's move on. Okay, let's put it a bit simply. On page 2, the product rule says this: if I have two factors, 3x plus 5 that is multiplied to 2x minus 1, this is a product, and because of that we use the product rule. The product rule says this: first, you will keep the very first factor unchanged. In other words, whatever was in the 3x plus 5, you write it as 3x plus 5. In short, you can also imagine it as we keep the first item untouched. Next, whatever that was in the second factor, you will now differentiate it. So differentiate the second factor will give us the number 2 and minus 0. But the 0 is understood, so actually you can just write the number 2. Okay, moving on. There is now a plus in the middle. Okay, make sure there is a plus. So plus over here. And then we reverse the order. Now we will keep the second factor untouched. So whatever was the 2x minus 1, we copy it down. Afterwards, we differentiate the first factor. So the 3x plus 5 differentiates becomes a 3 plus 0, which you can simply write as 3. Now, if we open the brackets using the distribution law, we're going to see a 6x plus 10 for the first part, and then a plus 6x minus 3 for the second half. And if you simplify this further, you're going to get a 12x plus 7. So this is an example of the product rule. Now the product rule can also be applied for cases where you do not see two brackets, but you still see an expression multiplied by another expression. This is again a product, and hence we must do product rule. Okay, keep the first. So 7x, just copy down. Differentiate the second. Now differentiate this is a bit complicated. This is actually chain rule. Okay, take note, you must do a chain rule for this part. So chain rule says the power 4 must come down, close the bracket, and then whatever was in the 3x plus 5, you leave it untouched, and the power now, give me a moment, the power 4, you must subtract 1. Now there is one more bracket at the back, that is if you go inside the 3x plus 5. If you differentiate this, you should see a 3 plus 0, which is just a 3. Now that completes the first half of the product rule. I'm going to highlight it in green. We have only done this part. Next is the plus sign. Now after which, we'll reverse the order. We will now keep the second factor, which was the 3x plus 5 power 4. and we differentiate the first factor. So differentiate 7x gives us 7. Now for this particular case, if you were to simplify, you're going to get a 3 times 4, that's a 12. 12 times a 7, that's 84. So we have a 84x and then bracket 3x plus 5 to the power of 3 for the first term. The second term is simply a 7 times 3x plus 5 power 4. Now, this question is different from the above question because you notice at the final step here in exercise 1b, you will notice that there are common factors. Now, what do I mean? Can you see common factors here and here? So now we must extract the common factor by factorization. So here I must perform a step on factorization. Now let's recall factorization for a question like x cubed plus x power 4. Now how do we factorize the common factors for this one? The highest common factor is x power 3, so I factorize it out. And we're left with 1 for the first term, and then the second term there is an x left over. Now to check that I'm on the right track, you must multiply back in and it should give you back the original expression. That's how you know the factorization is complete. So now we are going to repeat this process and factorize the highest common factor. In this case, it will be the 3x plus 5 to the power of 3. We are left with 84x on the first term and 7 bracket 3x plus 5 on the second term. Okay, do take note of my choice of brackets. I'm going to use a square bracket now. Square bracket. Now the second bracket can be further simplified. So that becomes 84x plus 21x plus 35, and we finally simplify it as this. 84 plus 21x gives 105x and then plus 35, and you can stop here. Alright, so word example B is important because the moment we see two brackets that are having common factors, we have to factorize it. That is important for this chapter. Now without further ado, then let's carry on to do redo example 1. Okay, you can spend some time to work on 1a and 1b using the product rule. These are simple enough cases. Work on them and check the answer when you're ready. You can pause the video now and check when you're ready. Alright, let's check the answers. Do you have these two expressions? Negative 20x minus 9, negative 2x plus 12. Make sure you have 1, 2, 3, 4 brackets at the start. Make sure there's a plus in the middle. And make sure you expand properly before you simplify. So that's part A and B. Alright, let's move to parts C and D. Now parts C and D, please try it out by yourself. Before you begin, just a reminder that for part D, this part later on will involve chain rule. Okay, chain rule is from topic 12.2. Okay, so try it now. Resume the video when you are ready to check the answer. Alright, let's check the answer. Okay, that's part C and D. Now part C should be rather straightforward. The issue probably is in part D. Okay, let me explain part D. Part D, the first part of the differentiation, you keep the first factor untouched, you differentiate the 3 minus 5x, that should give you a negative 5. Then you plus, followed by, you flip the order, you keep the second factor, the 3 minus 5x, and you differentiate the first factor, which, as I mentioned earlier on, involves the use of the chain rule. Now, the reason why I highlighted the number 2 in green color is because this is the part that students always forget to do. They always forget to differentiate the inside to give the 2. Now, after which, you carry on next step. You notice there's a highest common factor. Please factorize and then simplify whatever is left behind. Your final answer should be this. Okay, so these are parts C and D. We will now move on to the next page, E and F, and that is the part that I need to explain very thoroughly. So let's do that. Parts E and F. Now these are extremely important questions because these are the ones that are commonly tested for the N levels. Now, to do this question, we must first handle the one that has a square root. So y equals to 2x plus 3, and you need to rewrite the next term as 3 minus 5x to the power of half. Now, the moment I see a bracket and the power, this tells me that later on, I will need to involve chain rule. Okay? Now, let's begin the differentiation. dy dx. Now, I noticed that there's a product. There's a bracket times another bracket. This is again product rule. So, keep the first factor untouched. Differentiate the second one using chain rule. So, let me write in red. The power half comes down. Whatever was in the bracket remain untouched. The power half, you must subtract 1. Then don't forget, you must differentiate the inside. That gives us a negative 5. Now, this is only the first part of the product rule. Then we plus. Now, the second half, you reverse the order. You keep the second factor, 3 minus 5x square root. There's a reason why I wrote square root rather than power half. Okay, so take note. I'm going to write the square root, the original way of writing, because later on, we need this format. So rather than writing the power half, let's straight away just write square root 3 minus 5x. Okay, so fix this and you differentiate the first factor. 2x plus 3 factor differentiate gives us a 2, and we are done for the second half. Okay, next, let's do a bit of simplification. For the first factor, the first term, negative 5 times half gives us a negative 5 over 2. Now, the reason why I write it like that is because you will notice that 2x plus 3 has a positive power. It should be written on the numerator. But 3 minus 5x power negative half has a negative power. It should go below, right? And negative half says that once I bring it to the bottom, it transforms back into 3 minus 5x. Do you recall that? Now, I'm using this property here. I'm also using this property, which later on converts into 1 over square root a. This is what I was using. Then I plus the 2 put in front and square root 3 minus 5x. Now, the reason why I want to do this is because I am now faced with one fraction and then the other half is not a fraction. I want to combine these as single fractions. So to do the next step, what I'll do is this. I'll do something clever. I will put this over 1, and I will try to change this into a common denominator by multiplying something on top and below. Now, I will get my clue from this yellow denominator. So times 2 square root 3 minus 5x. The intention is to make sure they have common denominators. Okay, let's shift this aside. Okay, so moving on. Once I do that, I can draw one long line already because I'm going to combine them in one single step. The common denominator is 2 square root 3 minus 5x. Now, numerator, take note there's a negative here. So negative 5 times 2x is a negative 10x. Negative 5 times 3 is a negative 15. That settles the first term. Now, second term, let's do carefully. 2 times 2 is 4. Square root of something times itself. Recall from the chapter on surds. Square root a times square root a equals to itself without the square root. So what I'm left with is a bracket of 3 minus 5x. Now, after this, I can simplify the numerator. So negative 10x minus 15 minus plus 12 minus 20x. Okay, and the last step is just a simple simplification. I will get a negative 30x minus 3 divided by 2 times square root 3 minus 5x. And we are done for this question. Alright, now I will need you to repeat this method on part F. When you are ready, let's resume to check the answer. Okay, so work on part F and resume the video to check your answer. You may start now. Okay, let's begin. This is the solution for part F. Can you check if you have done everything correctly? And your final answer is as such. Alright, now the reason why we are doing all this is because, if you notice, for the next two questions in N-level, they will purposely ask you to present your work in a certain way as the final answer. So you have no choice but to combine the fractions, and that was what I was forcing you to do earlier on, right? We do not leave the answers as split fractions. We have to combine them because the question will ask you to combine them. This is one example. This is another example where the question specifically insists that you need to write the answer in a certain way. Alright, so this is roughly topic 12.3 on product rule. Now I'm going to skip these two examples. Let's move on to this page. Now this page, there is really nothing much. It is product rule still, just that instead of y, x square and x square, they use different letters. So we are not using dy, dx anymore. We are just finding, in this case, dA, dr. But the technique of doing the product rule is the same. Likewise, for part B, instead of y and x, they give you y and t. Okay, instead of x, they put t. So we are no longer doing dy, dx again. We are doing dy, dt. So be careful on what you write in the presentation, but the technique shouldn't change. I have decided to skip this page for you to practice by yourself. Let's move on to the theory part. Okay, this is the part that is important. Now that we know product rule, I will now need to link it back to the idea of the gradient function dy dx. This is known as gradient function. Now, gradient function enables us to find gradient of the curve at a particular point. For example, we do example 2. A curve has equations so and so forth. Calculate the gradient of the curve at a particular point. Now, this is reminiscent of 12.1, if you recall. In 12.1, towards the end of 12.1, we actually did one question that asked us to calculate gradient of a curve. And actually, there are only two steps. This was the question in 12.1. And the two steps are, step 1, find dy dx. Step 2, substitute the x value into dy dx, and voila, the answer is out. Now, what we are actually calculating is the gradient of the tangent line at this point. This is the tangent line. They want you to find its gradient. So that means that we cannot use our y2 minus y1, x2 minus x1, because now there is only one point. You cannot use that formula anymore. What we need to use is dy dx and substitution of a suitable x value. In this case, the only x value I can use is the 5. Okay, so using this idea, we will now look at this question. We have an x value, which is x equals to 1. We have the equation. So now to find the gradient, step 1, find dy dx. Now this one involves product rule. So I have listed all the steps and the combined answer is over here. That is step 1. Step 2 means you must substitute this x equals to 1. So step 2, you will arrive at the answer. The gradient of the curve is 11/4. That's all. Okay, so that's for part 1. Now for part 2, on the other hand, part 2 is a working backwards question. You have the same equation, but now instead of asking you to calculate gradient, they give you the gradient. The gradient is 0. You have to work backwards to find the coordinates. Now, how do I present the working? First, no change. You will still do dy dx. But in what extra thing you must do is, because they said that the gradient is 0, you must let dy dx be 0 and you solve. So dy dx is 0, you go and solve, you will find x is -2/9. Now the question asks for coordinates. That means they want both the x and the y. We have just found the x. Now how to find the y? you must use the x and put it into the original equation. Okay, sub it in and calculate the y. So that is what is done here. Okay, and once you got the answer for the y, you place the x and the y into the coordinates, and that's the answer for this question. Now with that, we have concluded 12.3. The rest of the questions is really for you to practice. They are about the same, and all of them involve product rule for this particular worksheet. So please go and try by yourself, but in view of the time constraint, we have to move on. Alright, so that concludes topic 12.3 on product rule. That's the end of this video.